Hello everyone, welcome to the next section, Analytics with Elasticsearch. In this section, we will understand how Elasticsearch can serve as your analytics engine. We will start with the basics of aggregations. In contrast to search, analytics deals with the bigger picture. Searching addresses the need for zooming in to a few records. Analytics addresses the need for zooming out and slicing the data in different ways. While learning about searching, we use an API, so let's see that. Create a new file, basics.txt. This is the API. All aggregation queries take a common form. Let us understand the structure. All aggregation requests take this form. The aggregations or aggs element allows us to aggregate data. The aggs element should contain the actual aggregation query. The body depends on the type of aggregation we want to do. We will cover these aggregations in this section. The optional query element defines the context of the aggregation. The aggregation considers all of the documents in the given index and type if the query element is not specified. If we want to limit the context of the aggregation, it can be done by specifying the query. The size element specifies how many of the search hits should be returned in the response. The default value of size is 10. If size is not specified, the response will contain 10 hits from the context under the query. Typically, if we are only interested in getting aggregation results, we should set the size to 0 to avoid getting any results along with the aggregation result. Broadly, there are three types of aggregations that Elasticsearch supports: bucket aggregations, metric aggregations, matrix aggregations. Let's start with bucket aggregations. Bucket aggregations segment the data in question, defined by the query context, into various buckets identified by the bucket's key. Bucket aggregation evaluates each document in the context by deciding which bucket it falls into. At the end, bucket aggregation has a set of distinct buckets with their respective bucket keys and documents that fall into those buckets. For people who come from an SQL background, a query that has group by is doing this. This query divides the table by the different values of column 1 and returns a count of documents within each value of column 1. This is an example of bucket aggregation. The next aggregation is metric. Metric aggregations work on numeric types of fields. They compute the aggregate value of a numeric field in the given context. For example, we have a table containing the results of a student's examination. Each record contains marks obtained by the student. A metric aggregation can compute different aggregates of that numeric score column. Some examples are sum, average, minimum, maximum, and so on. In SQL terms, this query gives a rough analogy of what a metric aggregation may do. This query computes the average score in the given context. Here, the context is the whole table, that is, all students. This is an example of metric aggregation. Then we move on to matrix aggregations. Matrix aggregations were introduced with Elasticsearch version 5.0. Matrix aggregations work on multiple fields and compute matrices across all the documents within the query context. Matrix aggregations can be nested inside bucket aggregations, but bucket aggregations cannot be nested inside of matrix aggregations. This is still a relatively new feature. Coverage of matrix aggregations is not within the scope of this course. Now we will look at preparing data for analysis. We will consider an example of network traffic data generated from Wi-Fi routers. First, we will understand the structure of data. The diagram here depicts the design of the system to help you gain a better understanding of the problem and the structure of data collected. The enriched records are stored in Elasticsearch in a flat data structure. Let's look at what one record looks like. So I will create a file and show you. This is the record. One record contains various metrics for the given end client device at the given time. First is the customer to which the Wi-Fi router and device belongs to. Then access point ID is the identifier of the Wi-Fi router or access point. Time of the record is in milliseconds since epoch January 1st, 1970. Then we have MAC address of the client device and name of the user to whom the device is assigned. Department is of the user to which the device belongs to. then application name or domain name for which traffic is reported. Category of the application is News. Network ID contains SSID of the network. Band is 5 GHz or 2.4 GHz. Location has latitude and longitude separated by comma. Upload total is bytes uploaded since the last report. Download total is bytes downloaded since the last report. Usage is total bytes downloaded and uploaded in a current period. Upload current is upload speed in bytes per second in current period. Download current is download speed in bytes per second in current period. Bandwidth is total speed in bytes per second, upload speed plus download speed. Signal strength is the strength between Wi-Fi router and device. Now that we know what our data represents and what each record represents, let's load the data in our local instance. Please make sure that Logstash is installed. One more thing we need to do is unzip the network_traffic_data.zip file, which should create a file network_traffic_data.json file in the same directory. You can see the files here. In the JSON file, you can see a large amount of records. After that, we have to update the conf file and ensure that it has the correct path of the JSON file. Then we create the index by executing this command in the Kibana console. Execute this command. You can see an exception that the resource already exists. If you do it for the first time, you will get an acknowledgement with value true. As I am executing it for the second time, I get this exception. Now, navigate to your command line and enter the path where conf file is placed. Execute this command. The process of data importing has started, and it will take some time as the data record is very big. After you have imported the data, verify that your data is imported with this query. You should see a response like this. Now that we have the data that we want, we can get started with learning about different types of aggregations. We will learn different types of aggregations on the data that we just loaded.